Math 2, Semester 2, Power Standard 1, Master Exam Review Guide. A bear is on top of a cliff looking down at a caterpillar on the ground. The caterpillar is 87 feet away from the bear. The angle of elevation from the caterpillar to the bear is 46 degrees. What is the distance between the caterpillar and the base of the cliff? Draw and label a diagram to represent the situation. Do not solve. So this is a trig word problem. You always want to start with a right triangle. And then let's just go back and underline the information and put it in the picture. So the bear is on the cliff looking down at the caterpillar. And the caterpillar is 87 feet away from the bear. So there's the bear, there's the caterpillar. They're 87 feet away from each other. The shortest distance between any two objects is the straight line that connects them. The angle of elevation from the caterpillar to the bear is 46 degrees. So right down here, angle of elevation is from the horizontal going up. What is the distance between the caterpillar and the base of the cliff? So caterpillar, base of the cliff. And that's it. You do not have to solve it. Number 2. Jack was sitting in a treehouse. So Jack's up in the treehouse and saw Jill sitting in the grass at an angle of depression of 53 degrees. So Jill's down here in the grass, and then we're at an angle of depression of 53 degrees. So angle of depression is always with respect to the horizontal going down. So that's 53 degrees. And then since alternate interior angles are congruent, that's also 53 degrees down in the bottom. If Jill is sitting 23 feet from the base of the tree, so Jill is 23 feet from the base of the tree, how far is Jack from Jill? So here's Jack, here's Jill. How far are they? That would be X. Number 3. An 18-foot ladder is leaning against a wall. So 18-foot ladder leaning against a wall. The base of the ladder is 5 feet from the wall. What is the angle formed by the ladder and the wall? So the ladder and the wall would be right there. Draw and label a diagram to represent the situation. Do not solve. So, done. Number 4. The graph shows the path of a water balloon thrown off the deck of a house. Fill in the blanks using numbers and units. The total time the water balloon is in the air is right down here. So that would be 8 seconds. The water balloon reaches its maximum height of, so we're looking right up here. So maximum height would be 25 feet. After 3 seconds, because the vertex is 3, 25. So after 3 seconds. The water balloon has a height of 24 feet. So 24 feet is right here. So that happens at 2 seconds. And again at 4 seconds. Part B, determine the range of the height of the water balloon. So range is your Y values. So our lowest Y value is 0. I want to do a square bracket because I want to include the 0 in my answer. And then my highest Y value is our maximum point up there. So 25 is my highest Y value. If the average rate of change from 2 to 6 is negative 2 feet per second, explain what that means in the context of the problem. So that would mean that the height of the water balloon on average decreases because it's a negative 2 feet. So that's why I'm saying decreases. If it had been a positive 2 feet, I would say increases. So decreases, and then I drop the negative sign because the word decreases takes care of the negative sign. So decreases 2 feet per second. And then we really need to say over what interval that's happening. So from 2 to 6 seconds. Roger kicks a soccer ball off the ground at an initial velocity of 32 feet per second. The path of the soccer ball is modeled by the function h of t equals negative 16t squared plus 32t, where h of t is the height of the ball in feet after t seconds. Use the function and graph provided to answer the following questions. The vertex is 116. Explain what it means in terms of the problem situation. So the x values are time, and then the y values are height. So basically, the soccer ball reaches its maximum height of 16 feet at 1 second. So the fact that it's the vertex, that means it's its maximum. It's the highest point on the graph since it's a concave down parabola. Part B, explain what happens at 2 seconds. So time is on the x-axis, 2 seconds is right here. So that's 2, 0. So you're basically on the ground. You're at a height of 0. So the ball lands on the ground because your height is 0 feet. Part C. Does the ball reach a height of 18 feet? If so, 1. If not, explain why. All right, so 18 feet, that's way up here. So no, the ball never gets way up there because our maximum value was at 16 feet. Part D, what is the domain of the soccer ball? So domain is your x values. So all the x values that actually make sense in the context of the problem. So we don't care about negative time, so we'll just start at a time of 0, and I'll use a square bracket because I want to include that in my answer. And then we don't really care about the ball going underground, so we'll stop at 2 seconds because that's when the ball hits the ground. And that's all.